Imagine you're at a trivia night and someone mentions IQ scores. Based on population, we know that the average IQ is 100 with a standard deviation of 15. Your friend proudly announces that his or her IQ is 135. You know that 135 is a high IQ score, but you want to know if it is unusually high. In other words, is it statistically significant? Assuming that IQ scores are distributed normally, we can use the range rule of thumb to find that out. Based on the range rule of thumb, we need to find the IQ scores that are within 1 and 2 standard deviations away from the mean. So start with your normal distribution graph with the mean in the middle. So we can find the values within 1 standard deviation by subtracting 15 to get the lower limit and add 15 to the mean to find the upper limit. And then within 2 standard deviations, you're going to subtract 15 again the second time, so that will be 70, and add 15 the second time, so that's 130. So based on this graph, we know that your friend's IQ score of 135 is significantly high, which means that it is unusually high. Now you're wondering, how does that relate to the z-score? Well, the number of standard deviations that I just mentioned is actually the z-score. So here's the number line for the z-score. So we know that at 115 is 1 standard deviation above the mean, so therefore the z-score for 115 is 1. And then the z-score for 130 is 2 because it's 2 standard deviations above the mean. Now what happens if it's below the mean? Then your z-scores will be negative. So we know that 85 is 1 standard deviation below the mean, so therefore the z-score for 85 is going to be negative 1. And then for 70 is 2 standard deviations below the mean, so therefore the z-score here is going to be negative 2. And therefore the z-score for the mean is always going to be 0. So again, the z-score is the number of standard deviations. So if you want to know exactly what the z-score is for 135, we can find that algebraically. So because 135 is above the mean, we know the z-score is going to be positive. And we're going to start with a mean of 100, and we want to know how many times do we add the standard deviation, which is 15, to get the result of 135. And to figure out how many times we add 15, that's the z-score times 15. So to find the z, we can solve this algebraically by subtracting 100 on both sides. So z times 15 equals 35. And then divide by 15. So therefore, z-score for 135 is around 2.33. So by converting 135 to a z-score, we can say something like this, that 135 is 2.33 standard deviations above the mean, which help us understand if it is unusual or rare score in the context of this distribution. To add to the earlier problem, imagine another friend tells you his or her IQ score is 72 this time. Now this friend knows that 72 is a pretty low IQ score, but he or she wants to know if it is unusually or significantly low. Based on this graph, we know that the z-score for 72 is somewhere between -1 and -2. So to find out exactly what the z-score is, we can do what we did earlier. So we're going to start with 100 plus, and again, z times 15 means that how many times we're adding or subtracting 15 from the mean to get the result of 72. So to solve for z, you subtract 100, so we have z times 15 equals to -28 divided by 15. So Z is approximately negative 1.87, which matches to our graph. A z-score of negative 1.87 means that 72 is 1.87 standard deviations below the mean because it's negative. Since negative 1.87 is not quite 2 standard deviations below the mean, the score of 72 is low, but it's not significantly low. It is still within the range where most people's scores will fall, but it's on the lower end of the spectrum.